Hi, this is just going to be a quick video on finding the p-values for, or the p-value for a particular test statistic that you might have found. Let me just fix this here real quick. So this is one of my questions. Obviously, this is data that I've collected a while back, and I do only have 38 data points, so hopefully you have at least that or more. And so I'm going to show you how to find a p-value. So the first thing that you have to do is you have to find a question that you want to copy, or a question that you want to test, right? And so I want to test this question against the population parameter, whatever that may be. So what I'm going to do is I'm going to choose the strongly agree and agree. And the reason being is because perhaps I feel that it's difficult to quantify the difference between someone who strongly agrees with this and someone who agrees with this. So we'll put the agree together, and then everything else would be, the not agree, if you will. When you look at your questions, whatever your responses are, some of them you can collapse, some of them you can't, especially if it's a yes, no, maybe type of question. But if you have a question like this, which is a Likert scale, then sometimes you just want to go ahead and collapse some of the responses. So I see that I have 21 of my participants strongly agree with the statement that all human beings have a basic right to healthcare. I have 12 that agree. And so together that's 33 out of my 38. And you can see that 55% of strongly agree, and then 32% agree. And so if I want to get my p-hat, then what I'm going to have to do is I'm going to have to, figure out, okay, so what's the sum of the two categories that I collapse? Now, when you do this, what you're doing in essence is you're creating this 5-response question into a binary question, basically a yes or no. Do you agree or disagree, right? And so doesn't matter how you do it. It doesn't matter which of the responses you choose. You just have to create it. It just becomes a binary because you'll have what you're looking for, and then you have everything else. So here I have 33 participants are the ones that agree. I'm just going to go ahead and name it agree. And I'm going to figure out what's I'm going to just go reduce this into 2 decimal places. So I'm going to figure out what is my p-hat, what is my sample proportion for this particular question. And I see that it's a 0.87 or 87% of my participants either strongly agree or agree with the statement that all humans have a basic right to healthcare. Now, there's some other documents that I want you to see. Let me make sure that I picked the right one. I don't think that's it. Hold on a second. That might have been it. So you can see here, this can be found in Chapter 7, and it's just in Chapter 8 I did talk about the alpha and the confidence interval and all that, confidence level and all that other information. Now there's a way for you to find the p-value for your test. For your test statistic. In this case, you can see that in the bottom of proportion, because you are testing proportion, so this is what we're doing. You have your formula. Now, for the two-tailed test, which is what I'm going to do here, the formula is 2 times 1 minus norm.s.dist, and then you have to put the absolute value. Now, the Excel sheet that I provide for you already has this information, so the only reason you would have to change it is if you decide to do a left or right tail test. So I'm going to go back to this. That's my p-hat. That's my sample proportion. That's what I got when I conducted the sample. So the next thing is, and of course this is going to be sort of made up, and so I do apologize. Here, there's several ways that I can do this. I can just input the p-hat if I want, or I can say, okay, 33 people agreed, right? And since I had 38, 5 people did not agree. Let me go to no decimal. And you can see immediately that my sample proportion ends up being 0.87, which is what I figured out before. Now my sample size is 38, so I have to make sure that I input that value. And then here what I'm going to do is I'm going to make up a value just so you can see the process. So let's say that a survey was conducted and they found that, let's go with 81%. So remember, this is what you're going to get from the sample or the poll that you copied. So the p-hat is what you got from your data, and then the p, the population proportion, is what you get from the sample. That's what happened, right? That's what you found of the question that you copied. Now, if I go along in this particular spreadsheet, I can see that my critical value is plus or minus 1.96, and again, this is what you're doing, but the nice thing about it is that you don't really have to sort of figure that out because the Excel sheet does it for you. I'm going to come back here real quick, and here you can see that if I'm doing a two-tailed test and I'm using an alpha of 5%, it's plus or minus 1.96, and that's what I'm going to use, right? Plus or minus 1.96. Then over here, I'm going to make sure that my formula for the p-value is the correct one, and so you can see that it is the correct one, right, for a two-tailed test. And then this value is my test statistic. So this value here is basically the probability of you rejecting the null hypothesis given that the null hypothesis is true, right? That's sort of like the best explanation. Another way that sometimes people describe it would be, what are the chance, if you will, that you get this value completely out of, random chance, if you will. Now, you also see that there's a conclusion here that says don't reject. And so what happens is then that we made the claim. So the null hypothesis was that the population proportion of people who agree with the statement that all humans should have access to healthcare is 81%. We collected data and we found that 87% of our sample did. So we're going to compare the 87% to the 81%. So the alternative hypothesis would be that the population proportion of people who agree with the statement is not equal or is different than 81%. We collected the data, we analyzed it, and then we got a test statistic of 0.92. Now, if you remember, when we look at critical values, since it's plus or minus, you have to think of the bell curve. So you have a minus 1.96 and a positive 1.96. Anything between those values is a non-rejection region, which means that you don't have enough evidence to reject the null hypothesis. In other words, you don't have enough evidence to say that it's different than 81%. If it's to the right of, if it's greater than 1.96 or less than negative 1.96, then according to your data, then you do have enough evidence to state that it is different than 81%. For this example here, we don't have enough data. Now I just want to show you that what happens, if my sample portion was still 87%, but let's say for some odd reason the population proportion was actually something like 68%, right? And so now you can see that my conclusion was to reject. I go back here and I look at my p-value, and look how small my p-value is compared to the previous one where I don't reject. Now the p-value is smaller than my alpha of 5%. There's about 1% p-value. My test statistic is 2.49, which means it's greater than 1.96. And so you can see that it just depends on, there's different factors, but basically what you're comparing is your test statistic to your critical value, right? If you were doing this by hand, or you are without technology, sorry, or the p-value to the alpha. Now, since you have this Excel sheet, everything's already in there. All you have to do is simply collect the data that you have, right? Sort of make a decision. This is what I'm going to look at. Then this value is inputted into your sample proportion, which is your p-hat. If you don't mess around with the Excel sheet, everything should work fine. If you have any questions, just let me know. But that's it. That's pretty much how you find a p-value for your test statistic for your hypothesis testing. Thank you.